guys, once again, we are here to learn another problem from Fluid Mechanics and Hydraulics, Chapter 3, Total Hydrostatic Force on Surfaces. If a 13 kg steel plate is attached to one end of a 0.3 meter by 0.5 meter by 1.67 meter wooden pole, determine the length of the pole above the water. The specific gravity of wood is 0.75 meter, neglecting the buoyant force on steel. In our diagram, let us identify the given value. We have height 1.7 meter of the wooden pole, specific gravity which is 0.75, and of course the area which is 0.3 by 0.5 by 1.7 meter. We are asked to solve for the length of the pole above the water. Since the buoyant force is equilibrium with the weight of wood and weight of steel, we can have our equation as buoyant force of wood is equal to the weight of steel plus the weight of wood. In all the given values, we have the specific density of water as 1,000 multiplied by the area of the wood that is submerged to the water, which is 0.3 times 0.5 times the height of the water, which is unknown. We can put y is equal to 13 plus 1,000 times 0.75, the specific gravity of wood, times the area 0.3 by 0.5 by 1.7. Only have one unknown, so we can already solve for the height of the submerged pole to the water. Y is equal to 1.36 meter. We already have the value of y. We can now identify the height of the pole above the water by subtracting the total height from the height of the submerged in water. H is equal to 1.7 meter minus y, which is 1.36 meter. Therefore, H is equal to 0.34 meter. That would be all for today. I hope you learned something from us. See you on our next video.